Great. Okay, so I'll talk to you about the project database that we've developed. Because since I just showed you that we've been collecting data from the summit of EIDA, which is important, but it's also very important to get that data in the database and out there to other communities and other people who want to have a look at the data. And what we've done is we've integrated this data with an existing archive called EIDA, or which is European, and it's a very big archive for all kinds of geophysical data. So like I said, Newton G is of course collecting variable gravity data from the summit of EIDA. I'm not sure if projects have done this before, so it's very interesting for us, but also for other people to look at. And we have to find the best approach to disseminate this data to a wide scientific audience, because it's of interest to many people. And you want to do that following the best available data management practices, which are these FAIR principles that Danielle briefly mentioned. So these FAIR principles, they're 4 letters. They should be findable for users. So if you go and explore or you do a project and you want to go look for data, the first thing you have to do is to go to like a portal. You study EIDA, you go to EIDA, you see what kind of data is available there. And you see, oh, well, there's all kinds of seismometers, but also a gravity station now. And you can maybe use this data in your project. And once you found this data, what you need to do is you need to download it. So it has to be accessible, right? You need to be able to get the data to use it, which is the A, so it stands for accessible, and it should be interoperable, which means that we need to use existing standards, so it can be used with existing software and data infrastructures. And the R stands for reusable. That means it needs to be well documented and reusable also in the future. So maybe 10 years from now, when someone wants to look at this data again, they can. And that requires us to build a mature data infrastructure, which is very difficult to do. And this comic captures that idea very well, I think. So in the situation, you have a lot of standards that already exist, and we say we have data. What can we do? We can build a new data infrastructure, do it ourselves, do it great, do it better than the rest. And eventually you end up with 15 standards, and that's something you don't really want. So often it's better to use an existing standard and try and develop your own. So that's what we've tried to do. Maybe the standard is not perfect, but at least it's something, and it's a standard, so people are using it already. You can very easily integrate with that standard, and you get all kinds of nice things from that. So what we've done is we've integrated with Orpheus EIDA, and Orpheus is quite a big organization that has historically focused on broadband seismology in the European Mediterranean region. So they started for broadband seismology, but they've kind of expanded to motion accelerometers as well, and all kinds of different data types. So more and more it's becoming an archive for different types of geophysical data. And EIDA is an initiative within Orpheus, and it's called the European Integrated Data Archive. So it's really a place where we put all this geophysical data in one place. And that includes that we write the data to existing file formats. So these are maybe, mini-seed and station XML for metadata. So if you've ever worked with a seismometer, you are very familiar with this, these file formats. And the original data management plan that we had was to build this custom database. But during the project and after collaboration with Orpheus, we said, okay, maybe we should try and add it to the existing archive of EIDA, because that will give us a lot of benefits. And I'm also very grateful to Orpheus for collaborating with us. I think this is a very key point to think of when you consider volcano monitoring that requires a multidisciplinary approach. So many will show in the afternoon that with gravity, you should take into account deformation at the same time, but maybe also seismology, infrasound, or types of measurements you can get from a volcano. And it would be really nice if all these data come from a similar infrastructure, so you can take them from the same place. You can build one system that interacts with that infrastructure, and then you have everything there. So this is what EIDA looks like now. There is in total more than 16,000 stations deployed across Europe. It's also an initiative in America, which is called IRIS, but for Europe, it's EIDA. So you can barely even see Europe anymore, but it's below all these stations. And this includes seismometers, mainly seismometers, but also microbarometers, stilt meters. There are some gravimeters, could be AQGs in there, but also some others. but in all sorts of things, sea level gauges, thermometers, distributed acoustic sensing, also in EDNA. And there also talks about trying to integrate GNSS data there. So you really have all sorts of geophysical data in the same place. And again, this is not an original ID. So Michel van Kamp, he's done a lot of work to integrate iGraph superconducting rotor data with EIDA. These are available from IRIS, so the American version of this archive. But it hasn't really been picked up yet by the community. So he's been doing it, but not many others have joined. But it's really useful because if you want to use this data, you can just go there and download it and use it immediately in 5 minutes. So that's a very great benefit to have. And so what was needed for this integration? Some software to take the output from the AQG and the WEGs and put it into this mini seed format. And Orpheus, they gave us a software development grant, which is great. So we could do that work. So we made 2 tools, so AQG to mini seed and WEG to mini seed. And it's quite simple. It converts this AQG and mini seeds, or sorry, AQG and WEG outputs to mini seed files. And it sounds kind of trivial, but there is some complications with that. But we've managed to do that. And that also includes the metadata there. One thing I'd like to say is that it's usable outside of Newton G2 because the AQG is being deployed in many different institutes. And if you're interested in maybe converting this to mini-seed and using mini-seed because it's a really useful standard format, you can use these tools because they are public. So just to summarize the benefits of integration you get with an existing infrastructure. You get all the products that run on this infrastructure. So for example, these web services, which is called Data Select. I have a small demo for that, just to show you how you can download the data. You get it for free because we just give the data to Orpheus, and because it's in a standard format, they know what to do with it. The system just picks it up and starts working on it. And there's all sorts of other products. So for example, the WF catalog, which makes an inventory of all the waveform data that's available. But also in let's say, a layer above EIDA, for example, EPOS. EPOS reads what's in EIDA. So if you put it in EIDA, it also gets absorbed into EPOS. So you get all of this for free. And that includes the client processing tools. So these work with mini seed data. And because it's a mini seed, these tools work. So you can just use them. So just an example from the WF catalog, which is a catalog of all the waveform data in EIDA. This shows you the date for the AQG versus the availability. So how much of the data is available in a day, for example. And you can very easily see that, for example, I'm studying earth tides and I need continuous data. So this part of the data is the part I'm interested in because it's continuous. I don't want this part, so I just need to request this piece of data. So it helps with the findability of the data that you need. So the status of the integration and the data that's available now. We've registered the network under 2Q 2020, so that's a network identifier. It's a standard way of doing that. And for the software, we've deployed or we've released the AQG to mini-seed and WEG to mini-seed software. We are using the AQG to mini-seed to rewrite this data and integrate the AQG data with Orpheus. We haven't done that for the WEG data yet because we're kind of lacking the quality assurance that what's being measured is actually volcanic. So we need to kind of think about this a little bit more. What we do want to do with the data before we integrate with Orpheus EIDA. And the data is under an embargo. So all data within Orpheus is open, so it's never closed, never restricted, but there may be an embargo that then is lifted a couple of years later. And the data that we have released publicly now is for the AQG between August 2020 until the beginning of 2021. And we have a DOI for the data set. So if you use the AQG data, you can cite this in your data availability statement, but the journals want nowadays. So we have a DOI for that as well. So just an example how you would, as a user, access this data. We use these web services, which is basically just a URL that you visit. But in this URL, you have some parameters. And this server that receives this request doesn't give you a website, but it gives you the data that belongs to this particular request. And it gives you this data in mini-seed format. And you would do the same for the metadata. So you just send this request there, and you get the data. So it's a way that humans can interact with the service, but also computers can do it because it's an interface that a computer knows how to read. You can just change the date in the script and get the data for next week instead of this week. So I just want to show you really quick how to download some data. If you want to do it now, you can do it. So I prepared a very simple script, which uses Optify, which is a client tool to process mini-C data, where you pass this read function, the first line. Normally you could put this URL in there, so it fetches the data from this URL, just from the internet. You don't need it, you can just get it there. But I've already cached it locally because I don't want to download the data now. So I've put it in this file, and you just read it. And I've written a function to plot this data. When I run this, normally it would go to the internet, pull the data for this week, and now you have it, so you can work with it. One peculiar thing maybe is that we are storing the raw data. So that's the top panel, which is the raw data recorded by the AQG. But we've also included this title model that's provided with the data so that the users can very easily subtract this data. But we are also always wanting to publish the raw data because if you're studying Earth tides, for example, you don't want to have this bottom panel, which is the residual between these three. You want to have the raw data with the tides included. For cable monitoring, you might just want to eliminate this. So we just provide that for user convenience as well. But the nice thing about this integration is that this is very easy to access now. So you don't have to write emails with Daniela, please give me this data. And then next week, oh, but I needed this data instead. So you just talk to this website, and it gives you whatever you need. Yeah, so that's the current status of what data is available and how you can reach it. So are there any questions?